Hey there. You ever get that feeling when you're coding that you're just writing the same stuff over and over again? Well, today we are going to crush that problem. We're diving into one of the absolute pillars of Java, inheritance. And we're going to do it by thinking about our code in a totally new way, not as a bunch of separate files, but as a family tree, complete with parents, kids, and shared traits. All right, let's get into it. So here's the game plan. We'll start with this whole family tree idea. Then we'll meet the parent, or the superclass, and the child, the subclass. We'll figure out exactly what gets passed down, the rules of the family. Then we'll unlock the real superpower of all this. And finally, we'll wrap it all up with the big takeaways. All right, let's jump right in with our first big idea, viewing our code as a family tree. The whole point here is simple, but it's a game changer. Stop repeating yourself. Inheritance is Java's brilliant way of letting us reuse code instead of rewriting it. I mean, really think about it. Let's say you're building classes for a dog and a cat. They both eat, they both sleep, they both make sounds, right? It feels so clunky and inefficient to write those same methods in both classes. It's a super common headache, and it's exactly the problem we're here to solve. Well, there is a better way, and it's all about creating this hierarchy, this family tree for our code. We can define one general ancestor that has all the common stuff, and then let all the more specific descendants just inherit those abilities automatically. So, first things first, let's meet the head of the family. In Java, we call this the superclass. This is our OG, our common ancestor, the blueprint for every related class that's going to come after it. To put it simply, the superclass, or you can call it a parent or a base class, is where we stick all the shared stuff. In our little pet example, it's the blueprint for what makes any animal a pet. It's the foundation that we're going to build everything else on. Okay, check out the code for our parent class. See how simple that is? We've got a class called pet, and it has one single method, eat. What we're doing here is establishing a really basic behavior that, let's be honest, pretty much every pet has. This is our common ancestor. So let's just break that down. Pet is the parent. It's holding the core DNA for our little code family. And right now, that DNA includes the ability to eat. So any class that descends from pet is going to get the skill automatically. No extra typing required. All right, we've got the parent. Now it's time for the child. In Java, this is what we call a subclass. And this is where that magic of code reuse really starts to shine. So what is a subclass? It's just a more specific, more specialized version of the superclass. It gets all the public goodies from its parent for free, and then it can add its own unique skills right on top. Now take a look at this code. We've got our dog class, but do you see that special keyword there? Extends. That one little word is the genetic link. It connects the child to the parent and makes the inheritance happen. Seriously, that extends keyword is everything. It's you telling Java, hey, this new class I'm making, it's an extension of that other one. This is what forms the famous is-a relationship. A dog is a pet. That's the core logic that makes this whole thing work. So just think about what this means for our dog class. Because it extends pet, it instantly knows how to eat. We never wrote an eat method inside dog at all, but it also has its own unique skill, bark. So it really gets the best of both worlds. It gets the shared family traits, and it gets its own special identity. Okay, so we know that traits get passed down, but, just like any family, there are rules. There are some secrets. Not everything gets shared. Let's dig into what a child class can and can't get from its parent. This chart lays it all out. Public and protected stuff, think of these as the family stories and skills that are shared openly. Yep, those get inherited. But private members? Nope. Those are like a personal diary. The parent keeps those to itself. And constructors, which are those special methods for actually creating an object, they aren't inherited either. Every class has to be responsible for its own birth, so to speak. Now for my favorite part. For real. We've seen how inheritance cuts down on repetitive code, which is awesome. But its real power, its actual superpower, is a concept called polymorphism. This is where things get incredibly flexible and, well, powerful. So what's the big deal? What's the real superpower you get from organizing your code into this family structure? I mean, what if I told you that you could treat all these different objects in one unified way? That's the superpower we're about to unlock. Look at this single line of code. This is everything. We are creating a brand new dog object, but look where we're storing it, in a variable of type pet. How can we do that? It's all because of that is-a relationship, because a dog is a pet. This lets us write way more general, flexible code that can handle any kind of pet. Doesn't matter if it's a dog, a cat, or even a fish. If you remember one thing, remember this phrase. It's the simple, logical truth that holds this entire concept together. Because a dog is a pet, we can treat it like one. This right here is the heart of polymorphism, and it's the true power of inheritance. Okay, let's pull this all together. We've gone through a lot. Parents, children, the rules of what gets passed down, and that awesome superpower. So what are the key steps you really need to lock in? Here's your 4-step guide. First up, find that common ground and build a general parent, your superclass. Then, create your more specific child classes using that all-important extends keyword. Third, just kick back and enjoy reusing code and typing less. And finally, the big one, leverage that is-a relationship to write some seriously flexible and powerful code. And that's a wrap. But I want to leave you with a little something to chew on. Now that you know how to model an is-a relationship, think about how many of those exist in the real world. A car is a vehicle. An employee is a person. A checking account is a bank account. The world is just full of these natural family trees. So next time you sit down to code, ask yourself, where can I build one? Thanks for tuning in.